This video is about the properties of real numbers. There are some simple but yet important ideas which are called properties of real numbers. And again, it goes back to remembering the simple stuff. It really makes a difference. So the first property of real numbers is called the commutative property. The commutative property. And there's two flavors of this. So the first one is of addition. And so when I was a student, I had to try to remember all these properties, just as you. And to me, this word commutative sounded like commuting or moving. And that's sort of how I remember this property. And so here's what the property says, and you'll see why that makes sense. So the property says that if you have to add two things, a plus b, well, that's the same as adding b plus a. We knew this. For example, we know that 4 plus 3 is the same as 3 plus 4, right? So commutative property, or the moving property, sort of help you remember, is just a way that says if you're adding two things, you can sort of move the order in which you write them. You can write the first one second and the second one first. Makes no difference if you're adding. And the second flavor of this is the commutative property, commutative property of multiplication. And again, you'll see how the commutative or moving, transporting makes sense. A times b, multiplication, is the same as b times a. And again, you sort of know this. Example, 4 times 3 is the same as 3 times 4. And it's useful because sometimes it's nice to be able to switch the order in which you add or order in which you subtract just by moving the thing at the back to the front, or the front thing at the front to the back. So this is a useful property to keep in mind, that if you ever encounter adding or multiplying, you have the right to change their order. The next up are the associative properties. Associative property. And just like the commutative property, it has two flavors. So associative property of addition, and the associative property says the following. So associative to me sounded like associate or hang out. So you'll see why that makes sense in this particular problem. So we know that according to the order of operations, we should do a plus b first. But the associative property of addition says, well, it doesn't matter whether you do a plus b first and then add c, or if you add b plus c first and then add a. It doesn't matter who you choose to hang out with first. So if a chooses to hang out with b and add together and then add c, that's the same as b choosing to hang out with c and then add a. Right? So associative property, and you could again do a simple example to convince ourselves that this is true. So we'll do 2 plus 3 plus 4. Well, is that the same? What is that? 2 plus 3 is 5, 5 plus 4 is 9. Well, would that be the same as 2 plus 3 plus 4? Well, 3 plus 4 is 7, 7 plus 2 is 9. So indeed, these two are the same. Okay. And we also have an associative property of multiplication. So in this case, a times b times c is the same as a times b times c. So again, it doesn't matter who a hangs out with first. If a hangs out with b, you multiply and then multiplies with c, that's the same as b multiplying c and then in terms of a. And we can again do a simple example. you can say, well, what happens if you go 2 times 3 times 4? Well, 2 times 3 is 6, 6 times 4 is 24. And what if we did it like this? 3 times 4 is 12, 12 times 2 is also 24. So you can see that it doesn't make any difference. You probably knew all this already, but it doesn't hurt to refresh. Now we get a fairly important one, and that's called the distributive property. Distributive property. Now on this one, you have to be careful because this is important, and you have to know this one because you're going to have to do this particular property both forwards and backwards. And what's nice about this property is it involves addition and subtraction as well as multiplying and dividing. So distributive property says if you have this situation, that is the same as AB plus AC. Okay, AB plus AC. So let's see, let's do a little example here. So example, what if we had 2 times 3 plus 4? Well, one way to do this problem is to add these two first, following the order of operations. That's going to give me 7, and then multiply by the 2 and get myself 14. Now according to the distributive property though, this is equal to 2 times 3 plus 2 times 4. Well, 2 times 3 is 6 plus 2 times 4 is 8, and if I add 6 and 8 together, I get 14. So you can see how those are the same. Now you're sitting there going, well, Professor, it's a whole lot easier for me to do it the first way than worry about this distributive property. And you're right when it comes to numbers, but the real use of this is when we get to doing algebra. Right? And you literally will be using this process forwards and backwards. So that's distributive property. Then we have a couple of identity properties. Identity property. So the identity property, basically identity, right? So I like to, when I was studying this again, I used to think of this as identity as in self. What gives back the self? So the identity property for addition would be when you add 0. So when you add 0, you get A. And it doesn't matter which way you add it, because we know the commutative property says it doesn't matter whether you add first the 0 or 0 second. Either way, you get A. So that's the identity property of addition, right? So this is the identity property of addition. And there's an identity property of multiplication too. So you can sort of imagine what that is, right? What gives you back yourself, or A? So A time in terms of multiplication, if you multiply by 1, you get A, right? A times 1 is A, or 1 times A is A, right? So again, we can do two very quick examples on this. 2 plus 0 is 2. Identity property gives back the 2. Example of this, 2 times 1 is 2. So there is the identity property. And then the last property is the inverse property. And when I again studied this, to me inverse meant sort of the opposite, right? So the thing that annihilates yourself. So the inverse of you, inverse property, right? What makes you go to nothing in terms of addition? Well, if you add minus A plus minus A is going to give you 0, right? Or if we turn the, because it's addition there, we can turn it around. We can say minus A plus A is equal to 0. And again, in terms of multiplication, if you divide, you get that A goes away, right? So if I have A and I were to divide it by A, Okay, I end up by the a's cancelling and you're getting 1. Another way of writing that, of course, is to say a times 1 over a, and that would be 1. Right? So examples of this as well. So in this case, that would be like saying 2 plus its inverse, -2. It's going to give me 0. And in this case, multiplication 2 times 1 over 2, that's going to give me 1, cancelling out the 2. The 2 was cancelled out in both cases. Okay, that's it.